Hey guys, this is Mrs. Raro, and this is my lesson on points, lines, and planes. Okay, so let's begin with the basic terminology in geometry, and that is called undefined terms. Okay, so an undefined term is the basic idea that you can use to define other figures in geometry. So such terms like point, line, and a plane are called undefined terms. In this diagram, we can identify a point here, right? This is an example of a point. This is an example of a line right here. And an example of a plane could be like the top of this table. So I'm just going to highlight the top. All right, color it in. All right, and that is called a plane. All right, now in geometry, you have to be very meticulous about your definitions, right? So let's start from a point, right? So a point is represented by a dot. So we use a dot to represent a point. It has no magnitude, it has no dimension, no thickness. All right, so these points are labeled with capital letters. This is point A, point B, and point C. Let's move forward to a line. So what is a line? So a line is a straight path. It extends in two opposite directions without end, and it has no thickness. It contains infinitely many points, and when you name a line, you use two letters, or you can use one lowercase letter. Here are some examples of a line. In this example, we have a line that's straight path, and it's extending in two opposite directions. So that's why there's arrows marked in this line. When you label a line, you want to use two letters. All right, so the labeling is use a line with two arrows, and you can use any two letters that are in this line. So let's say the line is, the points that we're using is AB, so this is line AB. So when you say it, when you label it, this is how you would label it. When you say it, this is how you would say it, line AB. Okay, so again, you can also use any two letters. So let's say this is CD, you would say line CD, and when you say it, you say line CD. You can also use a lowercase letter. So let's say this is line M, okay? So we don't label that. We just say this is line M, okay? So let's say this is line K. Again, same, there's no labeling to that. So this is just line K, okay? Let's take a look at the next example. What is a plane? A plane, right? Not the ones in the sky, right? But a plane is represented by a flat surface, so kind of like my diagram here. It extends without end, and it has no thickness, right? So a plane contains infinitely many lines. When you name a plane, very important, you have to use at least 3 points in that plane that do not lie in the same line. So for example, let's erase this very quickly, real quick, and then I will go back into it. So in order to have a plane, you need to use at least 3 points that don't lie in the same line. So let's name this point A, let's name this point B, and let's have a point C. So this is a plane in itself, and when you label it, you say plane ABC. The reason why this is a plane is because it has 3 points that do not lie on the same line. Okay, plain and simple. Get it? Okay, now let's talk about two more terminologies or definitions. Collinear and coplanar. If you look at the word collinear, there's a word line in there and there's a word co. So co means together and line is line. We just identified what that meant. So collinear points are points that lie on the same line. So in this example, we have a line here, and let's say we have point A, point B, and point C. We say that point A, B, and C are collinear points. Let's give it another example. Let's say this is point D, and let's say this is point E, and somewhere over here is point F. Points D, E, and F are not collinear. F, this point is not collinear with also line AC or line AB. Okay, so let's move on to the next terminology, and that is called coplanar points. So coplanar points, same idea. The word co, it means together, and plane is the plane that we identified here in this slide. Okay, so these are points that lie on the same plane. Okay, so I would identify such A, B, and C. These 3 points are coplanar because they lie on the same plane. Let's take letter D. A, D, and C are also coplanar points. So are A, B, and D, as long as they do as long as they lie on the same plane. Okay. All right, and now we move forward to other terminologies in geometry. Now we're going to use the undefined terms point, line, and plane that we learned earlier. Now we're going to use them to define other terms, right? So you've heard line segments before. So the official definition of a line segment is that it's a part of a line that consists 2 endpoints and all the points in between them. So here's an everyday example. These are just straws that are cut up and put back together. Other diagrams, so what we want to do here is, let's say we have a line, right? So let's start with a line. And let's say there are different points in this line. So say this is A, say this is B, say this is C, and say this is D, right? So in line AD, okay, there are different segments here. So we can talk about segment AB. So notice how I'm not using arrows. I'm just using a straight line to label it. So AB talks about this. AB talks about this segment, okay? And then so if we say line segment BC, it's talking about this segment, okay, and so forth. So now if we're talking about line segment CD, it's talking about this tiny segment right here. All right, so you get the point. Line segments are just consist of 2 endpoints and all the points between them. So this whole notion of all the points between them, right? So let's say we're talking about line segment BD, right? So line segment BD is from here to here, right? And all the points between them. Okay, excellent. So let's talk about the next one called ray, right? So a ray is a part of a line that consists of 1 endpoint, right? And all the points on that line out on one side of that endpoint. So I kind of use this diagram to represent what a ray is, because if you look at a flashlight, it's the light is only going one way, okay? So that's what a ray is. So if you think about a diagram in geometry, it might look somewhat like this. So the start of that would be an endpoint and the end of that would be an arrow. So it would be somewhat like this or like this or like that, right? So or like this. So whichever way, as long as it's just going one way. Now, when you name a ray, you want to start from the endpoint and then to the direction that it's going. So let's say this is point A and then this is point B. We label this ray AB. We do not label it BA. All right, because B is not the endpoint and A is not the direction that it's going. Okay, so this is wrong. Okay, and I'll keep that in there so that you understand it further. So let's do, this is C and let's say this is D. So this is ray CD, okay? And let's say this is F and let's say this is E. So this direction, so it's going down to E. So it's starting from F and it's going to E, and use that arrow, that ray arrow. All right, another example, so say this is G and this is H. So this is ray G, H. So it's starting from G and it's going to H. Okay, so very simple, array. Go with the direction. Okay, let's take a look at our last example, right? Opposite rays, right? And then I use this example because an opposite ray are 2 rays that share the same endpoint and form a line. So if you take a pencil and you put your finger anywhere in between this pencil, you have now created an endpoint, okay? And they're sharing the same endpoint and forming a line. So in this endpoint, from this endpoint to the eraser is one way. From this endpoint to the tip of this pencil is going the opposite way, and these are called opposite rays. So let's take a look at how that diagram might look like. So I'm going to start with a line, because opposite rays form a line. I'm going to give you 3 different examples here. So I'm going to put my finger anywhere in this line, right? And let's say that's point A. this direction towards the eraser is point B, and in this direction is point C. So we label that two rays. So we say ray AB going in that direction and ray AC, these are opposite rays. Okay, that's one example. All right, so here's another example. So say this is E, and say this is F, and say this is D. Okay, so we say E, D, that direction, going to D, and starting from E going to F, that direction, these are also opposite rays. All right? All right, let's take a look at a non-example. So we do not say, so let's say this is, let's say G, H, and I. All right, so we don't say that GH, ray GH, and then ray HI are opposite rays. Even if they're going the different direction, it needs to share the same endpoint. And if you say H here going to I, that means H was an endpoint that they're sharing, and that is not true. So this way, these are not opposite rays, okay? All right, let's keep moving forward. Okay, so a basic building block of geometry is all about a logical system, right? So later on, you will notice and you will know how to, what we call proof. And we start these proofs by identifying what we call a postulate. All right, so a postulate or axiom is an accepted statement of fact. All right, again, in geometry, we start with a very very simple matters, and then we just build from there, right? So just think about it as a single Lego, what a postulate is. A single Lego that's going to make up this whole building block, okay? All right, let's take a look at this example. My question here is, how many lines can you draw with 1 point, right? So here's 1 point. Let's call that point A. How many lines can you draw through that 1 point? Well, you might say there's infinite many lines you can draw through that 1 point, because let's draw a line. Right, I could go this way, I can go this way, I can go this way, I can go this way, right? All right, well, what about 2 points? So if I take this point A and then I took this point B, how many lines can you draw through those 2 points, right? So the answer is just 1. Right, you can only draw, sorry, my line was so crooked. So you can only draw 1 line through these 2 points, right? So let's take a look at line A, and then let's say C here, right? Still, you can only draw one line through those 2 points, okay? So we can make up a postulate, we can make an accepted fact based on the fact that if you have any 2 points, you can make exactly 1 line. And that is basically what a postulate is. It's just an accepted fact that you can use later on to build other facts. All right? That is very important. Okay, let's continue. Well, what about 3 points? How many lines can pass through them? Okay, so let's do an example here. So let's do 3 points. I always go back to point A, point B, and then point C. Right, so how many lines can go through them? Well, I can have no lines go through these because they're not in the same line, but I can say D, E, and F if they are collinear. There's only one, sorry. My line is always starting to be crooked because I'm clicking on the wrong thing. Right? So there's only 1 line that can go through 3 points, but as long as they're collinear. So here, these are 3 distinct points. They're not collinear, so there is no line that goes through them. And here, there's a distinct point, there's a distinct line where D, E, and F are collinear. There's only 1 line that can go through them, if and only if they are collinear. Well, again, that's another postulate. Through any 3 non-collinear points, so they cannot be collinear, there is exactly 1 plane. So there's 2 things you must know. In order for 3 points to form a line, they have to be collinear. But if 3 points are not forming a line, then they are 1 plane. Okay? The word intersect. An intersection or intersect is when 2 or more geometric figures have a set of points in common. So where do these 2 lines intersect? For example, two railroad lines, right? They intersect somewhere. Or this geometric tile, they intersect somewhere. So if you cross anywhere here, they intersect only at one point they have in common. One point they have in common. So we form another postulate and we say that when two lines intersect, they intersect exactly at one point. Okay, let's move forward. What if two planes intersected? So these two cardboards, where are they intersecting? This wall of the house and this wall of the house, where are they intersecting? And if you look at the figure here, it's very clear to see that they're intersecting at a line, okay? And that is yet another postulate. In this postulate, we say if two planes intersect, then their intersection is a line. All right. Awesome. Thank you for watching this video.